Hi everyone, welcome back to B.sc Chemistry Study Room. If you are new to this room, please subscribe for more video updates. And if you have already subscribed, please click on the notification button for more video updates. Today in this video, we are going to learn and solve problems under valence bond theory. So let's get started. Example, carbon at ground state forms carbon monoxide with two molecules of oxygen, but when excited forms carbon dioxide. The question said, illustrate this phenomenon using valence bond theory. So let's see the solution. Now the first step here is, this is carbon monoxide. First, bring this carbon and put it in its ground state. This is carbon at ground state. Then oxygen. This is oxygen at its ground state. So now after this, we degenerate orbitals from these orbitals of carbon at its ground state. First, we have 1s2. Then s orbital has no suborbital. Then 2s2 still has no suborbital. Then p. In our previous video, we know p has three suborbitals, px, then 2py, and 2pz. But here in the p orbital, it contains two electrons. So now we are to share these two electrons under this p. Then 1, 2. And these two finished. Then here 0. That means this pz orbital has no any electron on it. So now we move for the oxygen. We have 1s2, no suborbital. 2s2, no suborbital. Then p, 3 suborbitals. That means 2px, 2py, and 2pz. But here it contains 4 electrons, so we are to share these 4 electrons to these orbitals. That is, here we have 1, 1, and 1. 1, 2, and 3. It means there is a remaining of 1 electron here. So we clean these and put 2. We have 2, 3, and 4. That is 4 electrons complete. So now these are the p orbitals of carbon at ground state. We are going to use them. Let's bring them down. Carbon at ground state. We have 2px. Then here is a box that contains 1 electron of the px. And we have 2py. Then it's box up containing 1 electron again. Then 2pz. Then a box under having no electron. For the oxygen now, we go for the p orbitals in its ground state. So now let's bring them down. Oxygen in its ground state. We have 2px, a box under containing 2 electron under px, then 2py, a box also under containing a single electron under the py, then 2pz, a box also containing a single electron. So in our previous video, we learned that for any orbitals needs the maximum of 2 electrons. So now when we can see these orbitals, this one has only 1 electron, 1, 1, and 1. That means they all need 1, 1 electron. So this electron will liberate pair into this box. This one also will liberate into this box. So each shared an electron to form a covalent bond. So now here is the carbon. And this electron that transfer into this make a single bond as the shared electron, and also these make a bond. So now then the oxygen, or we can write it as carbon monoxide CO. Now let's read the question again. It says carbon at ground state forms carbon monoxide. So we have seen how to form this carbon monoxide with 2 molecules of oxygen, but when excited forms carbon dioxide. So now let's see how to form this carbon dioxide when carbon undergoes excited state. So here is the carbon in its ground state. We bring it down. This is 8. And also 2 molecules of oxygen in their ground state. This is the first oxygen and this is the second oxygen. So now let us peel these boxes. First, here we have 1s2. That means we have 2 electrons. 1, 2. And 2s2. 2 electrons. 1 and 2. Here we have 2p2. That means 2 electrons. 1 and 2. So now we can see that in the question it says when carbon undergoes excited state, it forms this compound. So here is the ground state of the carbon and this is the excited state of the carbon. So now let us peel the boxes. Here we have 2 electrons, 1, 2. Here is 2s2 and here is 2s1. This is because one electron liberates into this box because carbon undergo excited state. So here we have 1 electron and here is 2p3. Since 1 liberates into this, that means 1, 2, 3. So now let's peel up these boxes. Here we have 2 electrons. Here also 2 electrons. Here we have 4 electrons. 1, 2, 3, and 4. Also this oxygen 2 electrons here. 2 electrons and 4 electrons. 1, 2, 3, and 4. So now to form this compound, we go for each box that contains only single electrons. Here is 2s1 and 2p3. That means the valence electrons of carbon in excited state. Let's bring it down. Carbon at excited state. We have this box for 2s1, 1 electron inside. Then the next box which contains 3 electrons in it. 1, 2, 3 for 2p3. So now for the oxygens, we bring the p orbitals, the only p orbitals. Since it is in the p orbitals, we have two boxes containing single electrons. So let's bring them down. Here, oxygen at ground state. We have 2 electrons here, 1 and 1. Since the oxygen in the compound are 2, then we bring the other oxygen. Here is it, containing 4 electrons in the boxes. Here 2 electrons and here 1 and 1 as the 2p4. So now when we can see this excited carbon, it contains single electrons 1, 2, 3 and 4. That means these excited carbons need 4 electrons for it to be octet. So here for oxygen, it has 2 single electrons in each boxes. It needs 2 electrons. The other oxygen also contains 2 single electrons. That means it needs 2 electrons. So now this is 2p4 and also 2p4. So now for this to be octet, they will all share electrons to form covalent bond. This liberates here and also this one will liberate into this. This will liberate into this and also this electron will liberate into this box for the carbon excited one. So as these electrons are pairing from the oxygen to the carbon, they are all forming a bond. So now let's write them down. This is carbon. From this electron to this, one single bond. And from this electron to this, another single bond. Then oxygen. Then for the next oxygen, from this to this, one single bond. From this electron to that, one single bond and oxygen. Or we can write this as CO2. That is carbon dioxide. Thanks for watching.